Welcome back everyone. So today I have picked up a problem of mechanics from IRODOV. It's question number 248 from mechanics chapter. The first chapter of IRODOV. And majorly it is from rotational motion, you can say, because rotational concepts are involved. Obviously the equilibrium and NLM concepts will be there to solve this problem. Because in mechanics every chapters are almost correlated. So you can't just put in a single chapter and say this question is from that chapter, right? So the problem states that a uniform cylinder of radius r is spined about its axis to the angular velocity omega naught and then placed into a corner. The coefficient of friction between the corner walls and the cylinder is equal to k. How many turns will the cylinder accomplish before it stops? So this one is the cylinder and they have given omega naught angular velocity to the cylinder in anti-clockwise sense. Here I have written also. And with the corner walls, it is getting slipped on the corner walls. So obviously the corner walls are rough. So the friction will tend to prevent it sliding and it will eventually stop, right? Because friction will try to be in such a state where there will be no relative slipping, right, between the cylinder and the wall. Yeah, so I have drawn the free body diagram here that N2. Okay, so let me explain all the terms. Mg is the weight of the cylinder acting from the center of mass, as you can see. N1 is the normal reaction from this wall and F1 is the friction. Obviously you can understand the direction of friction as omega naught is anti-clockwise in direction, so this point will tend to slip in rightward direction on this wall, so F1 will be opposite to that. Similarly, because of angular velocity in anti-clockwise direction, this point in contact with the side wall will tend to slip downward in the figure, so F2 will be in upward direction and N2 is obviously the normal reaction from the wall. So I hope it's clear. And as the slipping is occurring, so maximum friction will be there, that is the limiting friction. So F1 and N1 we can relate. F1 is k times N1 and F2 is also k times N2. As for both the walls, the coefficient of friction is given as k, right? Now I have used the equations of translational equilibrium, where in horizontal direction I have done the net force 0, which will result in F1 equals to N2, because these are the only two forces in horizontal direction which will counterbalance each other. And obviously N2 I can write as F2 upon K, right, from this equation, where F2 equals to K times N2. And in vertical direction, using net force equals to 0, you'll get this equation, because Mg was in downward direction and N1 and F2 was in upward direction. So these two will counterbalance each other. So Mg will be F2 plus N1 I have written as F1 upon K, because F1 is K times N1, I have already told you. And F1 upon K is there, and F2 I have written as K times F1 from this equation, right? F2 equals to K times F1. So I've written it here. So if you just take the LCM and sum this, add these two terms, you will get Mg equals to this. So now I have got F1 in terms of K and Mg, right? So rearranging the terms, you will just get this one, that F1 is equals to K times Mg upon K square plus 1. And this one was our one equation, that F2 was K times F1. So you just multiply a factor of K in F1 and you will get F2 as K square Mg upon K square plus 1, right? This one is F1, F2. So I've simplified almost the F1 and F2 values in one or two variables. So obviously the given variables, because F1, F2, all these terms I have assumed, but K, Mg, this one, these terms were given to us. Now translational equilibrium part is done. Now we'll use the torque equation. Obviously it is not in rotational equilibrium because it is rotating. So there will be some net torque and there will be some net angular acceleration. So N1, N2, let me come back to the figure. N1, N2 and Mg, all the three forces are passing through the center. So if I wish to write the torque equation about center, I mean this point, center of the cylinder, these three forces will have no moment, that means no torque. Only F1 and F2 will have a torque contribution. So torque of F1 will be F1 times R and F2 will be F2 times R. And both are additive in nature because both the torques will generate some clockwise angular acceleration, right? So I have added these two torques, and obviously net torque will be equals to I times alpha. Alpha is angular acceleration and I for cylinder will be mr square upon 2. Obviously you know this value, right? Because that axis passing through center of the cylinder will have a moment of inertia of mr square upon 2. Obviously it is for solid cylinder. So just put the values of F1 and F2 here, these two values, right? Put F1 here and F2 here. I have taken kmg upon k square plus 1 common, and you will get a k plus 1 inside and mr by 2. Obviously 1 r gets cancelled from here, mr by 2 times alpha. Here m and m gets cancelled, so you just multiply 2 by r both the sides and you will get alpha as this. Now we are supposed to find the total angle rotated, sorry, number of turns, total number of turns during the subsequent motion. So if I can find the total angle rotated, I will just divide it by 2 pi, because in each rotation, complete rotation, it will rotate by an angle of 2 pi, right? So I have just used this equation. You use for 1D, right, that v square equals to u square plus 2as, and it is just the equivalent equation in rotation, right? So final state, the angular velocity is 0, so it will be 0 square minus omega naught square was the initial angular velocity, and obviously the angular acceleration is opposing the angular velocity, that is retarding. So I have put a minus sign here and minus of 2 alpha theta. So theta comes out as omega naught square upon 2 alpha. Alpha is known, right? So we'll put alpha value at the end. So total number of turns will be theta upon 2 pi, as I said. So you just put the value of theta here, and there will be one alpha term, and you will get the alpha value from this equation. And after putting all the values, it's just a calculation. You will get the total number of turns as r omega naught square times k square plus 1 upon 8 pi k times k plus 1 into g. And that is the answer for this question, and I hope it's clear and you have also enjoyed the solution. So thank you, and that's all for today.